Me over here, ready to rock and roll. Okay. All right. So I was doing some of the homework. So just so you know, the video that I put on the calendar was this real fast on phase shifts. Okay. I'm worried about this because I'm worried about you guys fractionally. You know how I am, and it's been proven we just don't do well with fractions. So what I have to do in this one in order to label all this information is this must be theta. So I can't have a coefficient in front of it. But wait, what is in front of theta if it's theta over 2? What is the number I have to pull out in front? What would that be? What's the answer to that, everyone? 1/2. So it is 1/2 theta when it is theta over 2. Okay, so I have to pull that 1/2 out. I never really wrote that second parenthesis. I guess I was syntactically, mathematically wrong back in the day. All right. And then here's the real quick kicker. What does this become? Right. And that's where the fractions and it just gives me anxiety. How many people don't know their fractions? And the answer is, well, 1/2 times what equals pi over 5? And the answer to that would be 2 pi over 5. How many people had that in their head? Anyone? 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 And the reason is, just like he said in the first video, don't just write your answer and not think. Think about if I threw 1/2 back in, then these would cancel and I would be back to having pi over 5 inside there. So good foilers, say it. Good factors. The whole point I said that since August is you check you factor, but then real quick think about a FOIL to make sure you have the right answer. I know this isn't a FOIL, this is a distribution. I also said good distributors are good factors because they take out a GCF and then check, is that correct when I throw it back in? He literally did the same thing. This is what kills me. And again, I know you don't like when I say it, but it's not pre-calc that kills students. It's fractions and the inability to deal with them. So just, keep that in mind. I'm not going to do these, but be careful when it is in proper formats and ready to graph and when it is not. Okay. And he made that point in the video if you were paying attention. Again, focus, focus. Ooh, naughty, 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 naughty. Okay. So we left 6 of those. I think you're okay on these. These I really, 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 really like. And I like this one. I think you give that a read at the end. It's kind of like how I started with the 3A readers. All right, but I'm not done. I like this one a lot. Which one do I want to pick? I think this one's healthy enough. Look at what it says down here. It says, if you read the directions too, give me both a sine and a cosine equation. This is great. This is why I said you could get a graph of a trig, one of these trig functions, and name it an infinite amount of ways, like what equation actually graphs it. So that's why I wanted to talk about that. They didn't really do that in the video. I just wanted to make sure I read one more time, just like in the video. Make sure you have a positive leading coefficient, and the closest phase shift possible. We're going to be spot on, so we'll be fine. Okay, so first thing that he did is, hey, locate that midline, and that's right there. So we already know one part of our equation. It's down 1, so we got a -1 no matter what equation I'm dealing with. And then it's all about your eyeballs and locating, either a sine or a cosine. And I really could go either way on this. I could go to the left or the right, and it would be equal. But I'm going to go to the right. And there's where I see one sine curve, right? So I see that sine curve. Okay, so 2 things I got to do. I got to figure out which way it got shifted so I could see that I went pi right. And again, this is what we're filling in. Y equals blank sine. Let's get all those parentheses in there. Blank for the B value, and then blank, I'm going to run out of room, for the right-left shift value, and then blank for the up-down shift. And I already have that. So that was -1 because that's our midline. And I guess I'm kind of like just thinking things out loud. I already know my A value, that is up 2 and down 2, and I had to have a leading coefficient, so up 2, down 2. Right? I already have my phase shift. I chose to go right, which, what does that become inside? Right pi over 2. Is it minus or plus? 3, 2, 1, go. Minus. So I went minus pi over 2. Look at this. I mean, we're nailing a whole bunch of stuff here. If this was a 2-point question, we'd have to give you 1.5. If it was a 4-point, you'd have 3 out of 4. Somewhere around there. If it was 3 points, maybe 2 out of 3, because the big one is the period value and the B value. All right, so what is this period from here to here? What is it from pi over 2 to 3 pi over 2? What is that distance? What distance is that? Pi. It is pi. Good. All right, if I shifted this back, this would be pi over, or take 3 pi over 2 minus pi over 2. You get pi. So I'm going to do that from here on out, and probably next year. 2 pi over b equals pi, and I'm just going to do cross multiplying. We could just switch these two. All right, that's another thing we could just say b equals 2 pi over pi. But anyway, this is a different 2 than that other one. This creates the period. And that one's done. Okay? Now, for the cosine, is there going to be any different period, or is it going to be the same period? So I have to write a cosine graph now. I have to write a cosine equation. Same period or different period? 3, 2, 1, go. Same. All right, it's going to be the same. All right, so most of these values are going to be the same. This minus 1, this down 1, this 2 for B, they're going to be the same. I'll prove it. All right, well, now I have to erase this and then identify a cosine kid. Well, I see it right away. Hi-ya. There's our cosine kid. Okay, I can locate it and then know what it is. First of all, it's going to be the same amplitude because we went too high, too low. It is going to be the same midline, so it is going to be minus 1 out here. This is what I'm talking about. It's going to be the same B value because the period is still pi. How could it not be? It has to be the same as the sine curve. The only thing I have left then is, which way did I shift it? Well, I shifted it left. How much did I shift it? If this is pi over 2, then what's this little value right here? Negative what? Pi over 3, 2, 1, go? 4, half of pi over 2. So I went pi over 2 to the left. All right? What does that mean is here? What's left? Plus or minus? It's actually plus. I heard a minus. Oh, I forgot my x. So it's x. Let me zoom in on this. I actually went left pi over 4. Left is plus. All right? And then close off those parentheses. So 2 up and down from the midline. Period is pi. 2 pi over 2 is pi. The cosine curve that I visualized was pi over 4 to the left. Okay? Love, love, love that question. And it just proves the point that we can choose multiple equations for the same picture. Okay? All right. So you do the same for 15 and 16. And then really give that one a try. That one's a nice one. And then I'm trying to figure out how to end this.